The Horizon tool in PV-syst allows us to define large, far-away structures that can shade a PV system. This includes mountains and other environmental features, as well as large buildings. In this tutorial, we will show you when it is appropriate to use this tool, as well as how to use the tool. PV-syst treats horizon shading by completely blocking the beam component of irradiation when the sun is behind horizon features. Horizon shading blocks direct irradiance for the entire PV system, as opposed to the near shadings, where only a part of the PV array is shaded at any time. However, there will still be diffuse irradiation even when the sun is behind a faraway mountain. You can read the help file to understand how PV-syst calculates diffuse irradiation with far shading. The Horizon tool should only be used for objects sufficiently far away so that, at a given time, the sun may be considered present or not present on the whole PV array. A rule of thumb for using the Horizon tool is that the shading obstacles should be at least 10 times further than the PV system field size. For example, if a PV system spans 10 meters, then shading objects need to be at least 100 meters away. Furthermore, PV-syst ignores the situation for which the whole horizon line doesn't exceed a height of 2 degrees above the horizontal. So how do we use the Horizon tool in PV-syst? Let's start from the residential demo project and work on the VC0 variant where the horizon has not yet been defined. From the project dialog, you can find the Horizon tool in the variance frame under optional parameters. This text box will show you the site information in a comment field. This text is informational and has no impact on the simulation. Underneath this field is the solar path that is drawn based on the site definition of the current project. On the x-axis we have the azimuth angle, and on the y-axis the sun height angle. This represents all possible sun positions throughout the year. The lowest arch represents the solar path on the winter solstice. The upper arch shows the solar path during the summer solstice. The blue lines show the parts of the solar path that are behind the photovoltaic plane. Here, the PV modules receive no direct beam irradiance, even if there are no features on the horizon. To manually draw a horizon profile, click on this red line. You can move points on the line using the left mouse button. You can add or remove new points by using the right mouse button. You can also manually define or modify points using the menu on the right. There is a Clear Horizon button to start again from scratch. While these manual drawing tools are available, in practice, it is usually better to import the Horizon file. To do this, click on the Read/Import button. Firstly, you can import Horizon profiles from files. You can load a Horizon profile from your workspace. You can also import a standard CSV file. In this case, take care to properly define the north azimuth angle and the direction of rotation of the azimuth, as some sources set north to 0 degrees and some set north to 180 degrees. Finally, you can use a standard .hor file from Meteonorm. PVGIS and Meteonorm allow you to import files directly from their online database. To do this, select one of these radio buttons and then click the button that says Import from Web. You will see a description automatically appear. Click OK. Now you can see the horizon applied to the sun path diagram. It is very important when importing horizon profiles to make sure that your site file has a very precise location definition. Small changes in latitude and longitude can greatly influence the horizon profile. Remember that 1 minute in latitude represents 1.8 kilometers, and 1 second represents 31 meters. Another way to say this is that 1,000th of a degree represents 111 meters. Here you can see the same sun path used in this example in Geneva, Switzerland. Here is the sun path in Belém, Brazil, which is in a subtropical region much closer to the equator, with the same horizon applied. You can see that the sun paths are almost vertical in the morning and evening, and that the azimuth range where the horizon line and the sun path overlap is much more narrow. Because of these two differences, horizon shading has a smaller relative impact at subtropical regions than regions further from the equator. To save the horizon profile for use in another variant or simulation, click on Save. Follow the Save File dialog and then click Save. This saving step is only necessary if you want to use the same horizon profile elsewhere. For the simulation purposes, it is not necessary. Click OK, and your horizon profile is now applied to your variant. We can notice that the green LED is now illuminated. Run the simulation, and if the horizon profile has features higher than 2 degrees above the horizontal, you can find the horizon profile in both table and graphical form in the report. If not, the horizon profile will be ignored. In this tutorial, we showed you how to handle far shadings for your PV system using the Horizon tool in PV-syst. We discussed when this tool is appropriate and how to use it to apply horizons in your simulations.